Hi, I'm Emmanuel, and this is the video presentation of my statistical machine learning assignment. We firstly looked at the prostate cancer data where we had 79 observations with 500 variables as our input space, which shows that we have a very high dimensionality. And input space they all contain numerical variables. Looking at the distribution of our response, we could see that they are almost the same. So we do not have an issue of class imbalance here. We went on to do a Kruskal-Wallis test statistic to determine our top nine predictors. And plotting them here, we can see that they can really differentiate between our classes, which is 0 and 1. And we went on to build a classification tree and with the whole data set, and we found this to be our classification tree with four terminal nodes. And we went on to plot the a box plot of the weakest nine from our Crystal test, and we saw that these ones are unable to differentiate between class 0 and 1, which really means that they are very weak predictors. Moving on, we did a correlation plot and saw that the variables, most of them are not correlated. They are weakly correlated, and with a few of them being correlated. So we might have an issue of multicollinearity. So performing an eigen decomposition and finding the ratio between our max and minimum gave us 17, which is a bit high from our threshold of 10. If it were below 10, we would say that it's normal, but above 10, we can say that there's a bit of multicollinearity. And building our six models, which is 1NN, 7NN, 9NN, and the tree, we saw that 1NN was having a zero test error, which made it had 100% area under the curve here. So it performed better than all the other models. And we went on to build three classification trees. We plotted them here. We can see that the CP 0.05 and the CP 01 had the same plot, same classification tree here. And plotting the bar plot of the doing a stochastic holdout and plotting the bar plot, we saw that there is no significant difference between all these machines because they were all trained on the same data, and we can see they all work the same. And an ANOVA test showed that there is a significant difference between the performance of our models. And on into exercise 2, we started with multi-classification of our MNIST data set. And after running the models and comparing the box plots, we saw that 1NN was the best predictor here, which had the lowest test error. So I went on to to show the confusion matrix of our 1NN, and this is how it looks. You can see we have a small deviance from the actuals, and went on to perform ANOVA of the test errors and saw that they are they are significant. So we reject our H naught and say that there's a significant difference between test errors with the models. And performing a binary classification where we picked the 1 label and 7 label to see how we can predict them. We used our 1NN, 7NN, 5NN, 13NN, and 9NN. And these are the training confusion matrix and our test confusion matrix here. And we plotted our ROC curve and saw that almost all the models worked perfectly. They were all in line. And lastly, we plotted we showed our true positive or our false positives, and we can see here that the label is 7. To the normal eye, the label is 7, but the machine was unable to predict it. It saw it as 1, which is which is a false positive. So in all, I was able to identify that 1NN was a very good model, and I think it's best for this data as well. So thank you very much.